Hi, my name is Filip and I'm a junior embedded firmware developer at FreeMDeb, and welcome to the FreeMDeb Bug Bounty Program livestream. The purpose of the stream is to promote the Bug Bounty program we've just started at FreeMDeb, to show you in practice how to work with our repositories as a contributor by doing a small contribution during the live stream, and to answer any questions that might arise during the process of contributing. The stream will start with a small introduction to the Bug Bounty program, and then after a couple of minutes we will just start working on a contribution. Please remember that it's just a casual live stream, it's not a presentation. Please feel free to ask any questions anytime, especially if something I do won't be obvious to you. So that's the end of the slides I wanted to show you. So the open source Bug Bounty program we've started at FreeMDeb. Everything you need to know about it you can find at the freemdeb.com website. It's in the Bug Bounty tab here. What is the purpose of the program? We would like to promote contributions to our repositories and give some financial compensation for contributors that want to help us. The amounts are depending on the difficulty of the bounty, but you can get from a couple bucks to even more than $500 for solving an issue. And for the most promising contributors, they might get job offers from us. Some time ago, one person got hired because of the Bug Bounty program. I might show you his contributions later. So let's just start. If you'd like to participate in this program, the first thing you need to do is find a task. There are a couple organizations on GitHub where you can look for issues marked as bounties. They will have some additional tags like bounty easy, which correspond to the difficulty of the bounty, and depending on the tags the amount of compensation will vary. So let's check how this looks like. We have links to the Dasharo and Zarus organizations. Most bug bounties at this moment can be found in the Dasharo organization and its repositories, but Zarus is also working on creating issues that will be selected for bounties. I've heard that the FreeMDeb organization also has some repositories that can have some bounties, but it's not very strict. If you find an issue in any of our repositories, well, there are no issues here, but if you find something and you'd like to work on it, you can contact us by any means. Like go to the freemdeb.com website, go to the contact tab. You can send us form to us. You can contact us via email, on social media. Well, obviously you can write a comment under the issue. So if something is interesting to you, please don't hesitate. The issue we will be working on today can be found in the open source firmware validation repository in the Dashar organization. Well, let's search for it here. Open source firmware validation. Yeah, I've created a new GitHub account which is not associated with any organization to make sure that I don't have any additional access rights that an external contributor would not have. So, the issue is number 980. We'd like to automate managing firmware binaries in OSFV. So let's say that this issue is interesting to us. What we need to do now is write a comment here, just like the instruction on the freemdev.com website says. Express your interest. Writing a comment under the issue is the best way to do it, because if ever anyone would find the issue interesting too, they will immediately see that it's taken by someone. So it can be something like, I'm interested in taking this bounty. From now on, you can think of this issue as taken by you and start working on it. To make the contact with us easier, we highly recommend to join our Matrix space. If you use Matrix via a client like Element, you can come to docs.dashar.com, just scroll a bit here, and under the community section you will find a link to the Matrix space. You can create an account on matrix.org or in our Dashar space, it doesn't matter that much. I don't have an account at this moment. I won't use Matrix on this stream, but please feel free to join us. There are plenty of friendly people that will help you if you ask for anything. Yeah, we've got a link to the Matrix space on the YouTube chat if you're interested in joining there right now. I'll be watching the YouTube comments and our Matrix space for any messages and questions. Feel free to ask about anything. So let's say you have created a comment, you have shown the interest in this issue. You can start working on it, and eventually, after some times, you will be assigned. Well, I have assigned myself my main account here. Perfectly, this Philipanda bug bounty account should be assigned here. I can't change this now because I don't have any rights to do it in this account. But after some time you should see your name here as an assignee. So now that we have taken the issue and we will be assigned in some time, we can just start working on it. The best thing to do first would be to read the issue, so let's do that now. So right now the testers are downloading the firmware binaries for testing from some source. The preferred way is to either download from dl.freem.com or from the corresponding repository, most often core boot. That's where we build the core boot plus UEFI EDK2 flavor of the Sharo. The CI system there builds the firmware. Let's go there and see how it looks like. You can see all the CI actions in the Actions tab here. The author haven't said exactly where to look for it, so me as an external contributor might not know where to look for the binaries. So that's a great moment to ask a question. What exact workflow does build the binaries? You can ask something like that. You can ask for that on the matrix space. It doesn't really matter. I suppose it's probably best to ask under the issue, because the questions will be documented for future reference. But anyway, I know from my personal experience that it's the Sharo workflow that builds the binaries. So recently someone, Mats Pijan, built the run the workflow on some branch, and here we have lots of jobs. Every single one of them builds the Sharo from one single platform. If we select one like the hard kernel Odroid H4, the step save artifacts uploads the artifacts on GitHub. You can download them. Unzip, and here's the firmware built by the CI. That's one way to get it. Another way would be to go to dl.freemdev.com. Oh, a bit slower. Yeah, here you can look. Well, I'm not exactly sure what path would it be. Sharo? Yeah, I think it's here. Oh, have a custom NV4X. Yeah, there are some binaries, but if only the name allowed for longer names. There are only final releases here, like v 1.3.0. There are no release candidates available, so dl.freemdev.com might not be as useful to testers as the CI, because we generally test release candidates and not the actual releases that are stable and available for our clients. Well, so what's the issue of that? This allows for user error. If the tester forgets to get and flush the correct firmware binary from the correct source, or reuses an old binary they already have without making sure it is exactly the same as the one that should be tested. It is up to the tester to provide a correct binary, to flush the platform with it, to pass the path to the file using an FW file environment variable. If they make a mistake here, then the tests might get invalidated. If performed on a wrong binary, then the results are worthless. So that's a big concern. We trust the testers on this, and that might not be perfect. So a solution the author of the issue would like is to, instead of pass a path to a file containing the binary and the local file system, it might be better to give some kind of version of the binary and to get it automatically from a known source. Examples: setting a URL to the Git repository where the binary can be found, and giving a version of the binary. Having this information, we might probably find the exact version. The binaries, I think I forgot to say this. The show workflow runs when a tag is placed on some revision. Let's see tags. So hard kernel Odroid H4 v091 RC2. So the second release candidate for the 091 version. That's probably what Matspian built before. So we might give a name of a tag, for example, on which the binary was built, and that should help us to get the exact binary that we'd like to test. Alternatively, just give a plain URL to the binary, direct download URL. Well, this way at least the file is not specific to the tester's computer. It will be downloaded, and it might be much easier to reproduce the tests in the future. If a tester uses a wrong binary, then there is really no way to reproduce anything. But if we know that the binary was downloaded from a known URL that still works, it might be much better for reproducibility. The fw file option must obviously not be removed because it would hinder the debugging locally. That's true. We should probably not remove it, because some other places might depend on it, and it might be easy to just pass it as a file if someone is debugging something quickly. There's an idea to cache the binaries, to not download them many times. It might be related to another issue. It's good to check such links. So making OSFV aware of firmware binary versions would allow us to set some DMI decode parameters automatically. What's this about? So we have a couple of DMI decode config variables set in the OSFV, and for each release or RC we need to change them: release date, firmware version. The DMI decode test cases are checking if the firmware version is as expected in the SMBIOS region. That's an issue, well, because most of the times the testers forget to update them. Because of that, the results of automatic tests needs to either be run again with the versions updated, so one run is wasted, or the result must be updated manually, which is not perfect. One that make the test always pass. Philip Lepla suggests we should set these values automatically. Most of them could be extracted from the FW file, firmware file. That's a good idea, although, as Michik says, there are two aspects of testing it. We want to test if the values are what is in the binary, and if the values are as expected. That might solve this issue because well, while running tests we would say which version we are testing. There will be no need to define what version is expected in some platform config variables. We will do it while running a test. So that definitely might solve this issue, or at least make a couple of those variables automatically settable. When we work on this issue, we might try to update this issue here, which is linked here. If we manage to solve it, then that's great. That's two birds with one stone. Where's the value to a user? Better reproducibility. Well, we said that. Freeing the testers from managing firmware release binaries. When a tester tests a couple binaries a week, well, they might have problems with keeping them tidy. They might confuse two binaries. It's a human thing, right? It's better to automate such things. Separating release binaries from possibly multiple debug binaries built by the tester. Again, the same thing. We don't want to give the possibility of testing a wrong binary to the testers. There's a problem though. We have a couple of Ashara flavors. It's not always core boot plus UEFI. We have heads, we have CBIOS, and if we go to the Actions tab on any of those repositories, there are no workflows here, so we won't be able to download anything from those CIs. That's something we need to take into account. One way to take that into account would be to just not support those repositories. Most of the releases are core boot plus UEFI anyway, but if we implement the firmware URL options, then we can give a URL to anything. OSFV or rather robot framework will save this variable, and in the logs you will be able to check from where the binary was downloaded. Anyway, can we increase the font size? Piotr asks. Let's try 150%. Would that be better, Piotr? Or should I increase it further? Well, let's assume it's okay for now. So we know what is expected from this issue. We want to give OSFV the possibility of downloading firmware binaries from a known source to free the testers from the duty of keeping care of them. If we come back to this list here, oh, Piotr says thanks. So let's keep 150% here in the web browser. Possibly we might need to increase the font in the terminal later, but I'll just try to keep that in mind. So, fork the repository. We don't have any access rights to any repositories right now, so the only way to contribute is to create a fork on our GitHub account. Let's go to the main page. Code. I have created an SSH key on this computer, so I will use an SSH URL to access the repository. Let's go to desktop. There's nothing here, so that might be our directory where we will work on this issue. Do we have Git here? Oh, we have Git. That's great. Git clone. Let's unlock the SSH key. Alright. We have the repository. I thought about using VS Code for working this issue, but it might be better to use something like Vim. We do not have Vim. It is a fresh installation of Fedora. To make sure we start from a common place. So let's install NeoVim. Is it NVim or NeoVim? Can't remember. Install, sorry. Oh, that might take a while. Let's open another terminal window for now. Let's see what do we have here. I'll just reopen the issue quickly. We've lost it along the way. Was it 980? Yeah, okay. So let's check how the open source firmware validation repository works. We can go to the README and see how to use it. A big warning. Well, it's a bit concerning. We are in the process of migration and multiple major reworks. Nothing to worry about here, really. There are some explanations how we test our devices and the firmware. We have a couple of possible configurations for the test stands. We can use the remote test environment and a son of smart plugs to access the serial console and control the power. We can use plain RTE to control the power too if the device does not take much power. We sometimes use iPXE I mean by KVM KVMs to access devices. Sometimes we run tests over the SSH. It depends on exact device. We have 4 modules containing tests. We won't be that interested in the tests. We won't modify any specific test. We want to modify how OSFV works on a greater scale. Let's say command completed. We have Vim, rather nvim. Yeah. our possibilities have grown significantly now. Let's see. Oh, getting started, finally. We have already cloned the repository. We've entered it. We've entered it here. Let's see, we are already on branch developed, so we don't need to check out. It's the main branch. By the way, we need to download the submodules. Let's quickly copy this command. We will need to create a virtual environment. Well, that's not required, but it's recommended so you don't break any of your Python packages in your system. Then should be enough, right? We are not working on Raptor Talos 2 platform. We'll probably work on any other platform, so we will download the requirements.txt file. Isn't it a bit annoying that I moved the windows like that? Anyway, pip install requirements. OSFV test data is a repository where we have some larger files and dependencies for some tests. It's specific to a couple tests that need some additional data. It probably won't be required today. It's recommended to reinstall any dependencies if you will work with the environment again in the future. Well, if you change a branch and requirements change, it's wise to reinstall them, but it won't be needed today. Some additional tips. There's a lot to do in OSFV, but let's get to the point. Running tests, that's what we are interested in. Oh, here's the firmware file variable. Path to and name of the corporate firmware file. This is usually not required when running single tests or suites where flashing is not necessary. Although some tests will flash the platform, and that's where the firmware file variable will be useful. So here's the here's our culprit. There are a lot of parameters to remember, like the IP address of the device, the IP of the RTE, the son of smart plug if used. Generally, we are using run.sh wrapper for the robot framework. It makes testing much easier. You use it by setting environment variables like device IP instead of passing them every time you run a robot. What I like to do is create a file, a bash script where I will keep all the environment variables. We will be running tests on QEMU today. So let's create the file with the required variables. is nvim. I have an alias on my laptop. RTE/IP. When testing on QEMU, well, the device is our device. The RTE/IP is 127.0.0.1 localhost. Config. Config corresponds to the platform config in the platform configs directory. Let's see what we have there. Platform configs. QEMU.robot. How does it look like? Some comments, some resources included. There are a lot of variables defined for some of the platforms. Every device we test is unique, and it requires a unique approach. So some devices can be tested via telnet to access the serial console using an RTE. When it comes to QEMU, we don't use an actual RTE, but we still use telnet to access the virtual serial console of QEMU. There are a lot of flags used to determine which tests are supported on a device. Some devices might have some more interesting settings, like let's check some of a custom laptop. We have the CPU frequency defined for some tests that check how the CPU works. There's a lot to see here, so you don't need to know how every variable is used. When adding a new platform, it's wise to look through them and decide what you should and should not define. All of the variables are defined in the include default.robot file. Every variable used by OSFV is defined here. Some have some default values, like flashing method is external by default using an external programmer. Some of them have to be done, and they must be set when creating a new platform. Anyway, let's I think we should use the QEMU.robot config for running tests on QEMU. So let's write it down. Again, nvim QEMU.robot. We just give a name of the file here without the full path. It's not specified here. Well, maybe it should be. That's maybe a thing for the future. And is it everything? Well, it's the firmware file might also be required. We don't have a firmware for now. Let's try to run tests on QEMU with that. For running QEMU quickly, I recommend to use a script that our CI uses to run self-tests. If you know exactly what you are doing, you can run QEMU manually, give all of the flags how you want them to look like, but it's much easier to use the script at script CI QEMU run.sh. the most important parameters you have to set for running tests in QEMU is machine Q35, because we only support this mainboard, and the firmware hyphen drive option chooses the firmware file that will be run on the QEMU. So let's try to run this script. Here's the help. QEMU run.sh options are optional, QEMU mode and action. We'd like to run QEMU in graphic mode with a window opened to look what's happening there. We don't need to use it via serial console. And for now we are interested in running a machine with only the firmware booted. We don't need an operating system. So let's do graphic and firmware. The required file QEMU q35.rom is missing. It's the firmware file that QEMU will run. We don't have it here. It is automatically downloaded from our repository. Here's the QEMU v021 release. It's the latest one. Here's the file that is downloaded. So as you can see, we know where this firmware comes from. That's great, but we are not so sure about it when some tester runs a test on a device. QEMU v021 RC1. There's a known bug that the name contains an RC1. It's not important for now. For the sake of it, I will show how to build the Sharo Coreboot plus UEFI flavor now, because that's a good thing to know. It won't be needed today because we won't be modifying firmware in any way. We can close QEMU. It doesn't work. Let's just kill the process. For that we will clone the Coreboot repository where the firmware is built, specifically the Coreboot plus EDK2 firmware. Okay. Oh. Yeah, right, console font, sorry. I have chat opened on another screen and it went blank. Let's increase the console size about 150% too. That should be better. In the meantime, while the repository will be cloned and the firmware will be built, let's try to actually run a test on QEMU. Let's get the variables again. QEMU vars. Oh, the repository have been cloned. Coreboot. We are on the Sharo branch. It's the main branch of the Sharo on the Coreboot repository. If you are not interested in fiddling with the firmware deeply, all you need to do to build a firmware is use the build.sh script. You give one parameter to it, the name of the device the firmware will be built for. We will build the QEMU full version. It contains all of the menus in setup menu, even if they are not supported on QEMU. It's good for performing tests of the setup menu. To make sure that we are using the firmware we have built just now, let's modify the config file for the QEMU platform. In the corporate repository, the config files, which are the easiest way to mess with the Sharo firmware in the corporate flavor, are in the configs directory. It's called emulation QEMU Q35. All menus. That's the config. We can modify the version name of the firmware. That should be enough to make sure that that's the firmware we are using. And let's just build the firmware. It was QEMU full. We don't have Docker. Docker is required to build a firmware because of a development container that contains all the tools required to build the firmware. It takes a lot of time to build all of them, so it's better to use Docker for that. Well, maybe let's try to start doing anything. We are now using the main repository of the open source validation, but we must create a fork to do anything, because we can't push directly to it. So let's do that. We can do it, for example, from the GitHub UI fork. Let's not change the name. Let's create the fork. Here it is. We have a fork of the repository. If I'd like to push anything, we can see that we cannot read from the repository. Please make sure you have the correct access rights. So let's now just quickly change the URL of the repository to the fork we've just created. Git remote set URL. You can obviously also just clone your fork by copying the link from here. What I do here is a bit going around. you will change the URL to the origin remote. Here it is, that's our fork. Now we should be able to push to it. Everything is up to date, so we have the right to push to it. Docker has been installed. It's not running though, I think. Okay, now it's going. So what would be a good place to start? You would like to create... I think I have lost the issue again. Here it is. You'd like to create either firmware repo or firmware version or firmware URL environment variables instead of firmware file, to make sure that the firmware used for test is reproducible. Matspian suggested that we could also define the URLs in the platform configs instead of using environment variables. That might also be a great option, because for one device we are probably using one flavor of the Sharo. Well, it's not the case for Nova Custom laptops, because they have either Core Boot UEFI or they also support the heads firmware. So I think it might not be as easy to implement the suggestion. Maybe we would need to create multiple platform configs for every Dasharo flavor. I think that might be a good thing to improve this contribution in the future if you would have time, but it's just an improvement, I think. The most important thing is to allow OSFV to unload a firmware binary from a remote source instead of using a local file. Maybe let's see where the firmware file variable is actually used in OSFV. It's either must be read by robot framework in some way, or maybe it is passed as some kind of parameter to robot framework. The author didn't say exactly how they use it, but if we look here, we can see that I don't think the firmware file is actually passed in any of the examples. So it is just document. Oh, here's a firmware file used. So it is just set as an environment variable when running regression.sh, for example. Let's see what it does. the file. Let's search for firmware file. They are required for full regression. They must be set, and where is this check and variable? Something is sourced here. So maybe this check and variable is implemented here. It's in script directory /lib/robot.sh. lib robot.sh. Check and variable. Let's look for it again. Oh, FW file option. It looks like an option to robot command for setting a variable. Oops. Aren't we using the virtual env? I think we are not. I wonder if the help defines this -v flag. Let's look for it. Oh, I think we've had it, but okay. Variable name value set variables in the test data. So looks like this firmware file is passed to robot framework as firmware file. So that will be the name robot framework can access the variable with. Because the FW file option is then. Is it passed anywhere? Oh, at the end of the script we are creating a command string which has the options appended to it and it's evaluated. So possibly we should look in the robot files for the name FW file. Maybe let's just grep for it. We are not interested in scripts that much. Yeah, it's accessed somewhere. Keywords.robot. Wasn't a firmware build. I think we haven't initialized the repository or something. If that takes too much time and there are issues, we might resign from building the firmware today, because it is not strictly required. We already have a firmware for QEMU saved here as QEMU q35.rom. So how could we implement this? I think we could either add something to the robot files that would then load the file if some environment variable is set, or maybe modify the wrappers scripts. They could then load the file and replace the firmware file variable with a path to a newly downloaded file. I think the first option would only be possible if Robot Framework is able to read environment variables by itself. Maybe let's see if that's possible. Robot Framework documentation. User guide. Let's check the latest version. Search for environment variables. Oh, Robot Frameworks allows using environment variables in the test data using the syntax %, and var name. So that's a way to pass the URL. They are limited to string values. Well, a URL will be a string, so that's not a problem. It's possible to specify a default value that's used if the environment variable does not exist by separating the variable name, the default name, with an equal sign. So that's a way we could pass this to Robot Framework. I think let's create a tiny test case where we will try to test if this works as expected. There are some small test cases that don't actually test the firmware but do some utilities in the util directory in OSFV. Let's maybe copy one of them and modify it. Test.robot. So we can see how a test case works. We have some libraries included for telnet, so connecting via serial console, SSH library. Some other robot resources are included here, keywords. So first, a prepare test suite keyword is run. Okay, let's just delete a couple lines. Let's see if we can access an environment variable from a robot file. what could it be called? Well, firmware URI. That's what we would like to use to solve the issue. Log to console is a keyword in robot framework that will show any string to the console. Let's maybe say hello first. To look for what you can use in robot framework files, you can explore the repository, look in the test cases or look in the documentation. I know this right now. We won't need to run any preparations for this test, so let's just try to run that. Robot util test.robot. It said hello, but an environment variable firmware URI is not found. So let's try to set it. 1, 2, 3, 1, 2, 3. Oh, here it is. It has read the variable. Without this, we can't access it. Let's check if exporting the variable works. Oh, it should be accessible. Yes, it is. I think building the firmware still isn't working great. Now it's possible that we might need to reboot the device after installing Docker. Well, we have started from a fresh installation, so there might be some issues without a reboot. We haven't done a proper system update too. Let's just trash this idea for now. We don't have time to debug this for now. If you would have any issues with building the firmware, if I would really be an external contributor right now, I could ask on the matrix space for help. I could create an issue that something doesn't work. At first it would be best to check the repository and see if we haven't missed anything. I won't do that now, but that's probably the first thing you should do if you encounter any issues. Remember that we really want for you to contribute to our repositories, so if you have any problems, just ask. Everyone will be happy to help you. So let's close this core boot repository for now. Because of this mishap, I forgot to actually run a test case on QEMU. So let's first try to do that before we continue with experimenting and implementing the functionalities for this issue. We've started with creating this QEMU vars file. Let's modify it so that it includes the firmware file we will be using today. It's not built by us, but it will be enough for now. It was built by the CI of the core boot repository. I will copy the name so that I don't make a mistake in the name. Firmware file equals qemu q35.rom. This time we need to give a full path to it. It doesn't need to be absolute. It can be indirect. There's no need to give // here. A name is enough if the file is placed in the main directory of the cloned repository. What I always like to do when testing is to create a directory where I hold the binaries, something like ROMs, for example. This way, by putting this character in the front, it will stand out easily. We can move this firmware file there. Why not? But we need to modify it in the file with the environment variables. The path doesn't need to be absolute, but we need a path here. So, what test could we run? Let's see. Something that will end quickly. Maybe UEFI shell. What would be the easiest test to do? Or fe.robot. Let's see. UEFI shell. Powers on the device. Enters the boot menu. Enters the UEFI shell in the boot menu. Reads until the prompt is shown. Writes DH. Presses enter, so executes a DH command. Reads everything from the serial the terminal until the prompt is found again, so gets the output of the command. I'm not sure what it is supposed to test here, to be sure, but it looks like a pretty simple test. Although we won't have an UEFI shell here. It's just plain firmware, and we have dropped the support for UEFI shell in this release. Maybe let's check this fe.robot. Boots into some OSs, that's also not perfect. Maybe custom boot menu key. I think that's a pretty simple test case. Yeah, it just reads if the boot menu or setup menu keys are present when you boot the device. So it checks if when you boot the device, it shows you what to press to enter the setup menu. Let's try to run that. Let's make sure that we have all the variables defined, and we can use the robot framework wrapper to quickly run the test case. Scripts run.sh, the shadow compatibility, UEFI.robot. Oh, that's something we have implemented quite recently. The testers are not allowed to run tests if the Git tree is dirty. It is definitely dirty. We've modified some files. We are not interested in making reproducible tests for now, so we can use allow dirty environment variable to skip this check. No, I shouldn't have given .robot in the config file in our variables. It's appended automatically. Let's try that again. Connection refused. Well, we are not running QEMU. That might be a problem. OSFV won't start QEMU automatically. That's why we need to run the script I talked about before. Scripts ci QEMU run.sh. It was graphic firmware, I think. But it's downloading the firmware again. I think we can pass it. Okay, so QEMU is running now. Let's see if it can connect to it. It tries to check out the device using our Snipeit system, where we keep track of our devices. Well, we don't have access to that from outside network, so we have a flag for that: Snipeit no equals 1. Snipeit makes it very easy to access devices in our laboratory. So let's try with this. The tests are skipped. We can check the log. I have pressed Ctrl plus left mouse button to quickly open it in the web browser. We can see the logs of the tests execution here. So UEFI interface tests are not supported because UEFI compatible interface support is not true. Let's quickly try to modify the platform config of QEMU. To tell Robot Framework that this is indeed supported. Again. Oh, that's not the test case we wanted to test. It tries to boot into Ubuntu. We want to test custom boot menu key. So let's try that again. And pass. So it has found that the key to press, in this case F2 or F11 I believe, is shown when you boot the platform. So the test has passed. Yeah, it's F2 or escape to enter the boot menu. I have just pressed escape, so the boot menu should open. I have pressed it too many times. So it returns to the setup menu. Well, it doesn't matter for now. So that's how you would run a test case. This time this exact test case is not tested on QEMU, but it can very well be supported. There was just no reason to test it before. So we can access the UEFI, firmware URL environment variable from inside a test. Let's try to actually download something. I wonder if there is a way to download something built in to Robot Framework. Let's search the documentation. Download packages, pip. Oh, that's everything. wget, that's the command I would use probably to download something from the terminal. There's no in no place it is mentioned. Maybe HTTP, copyright, installing Python. I'm afraid there might not be a built-in way to download something. Here just a variable is set to a URL. User keyword syntax, so here are some example keywords defined by users. Okay, so maybe we can run a command on the local machine. I think we don't want to download the file on the device under test because, well, it might not have a firmware installed even. We would like to download it locally, so maybe run a command, run. Let's maybe just Google it. Stack Overflow. Perfect. We have some kind of process library and run process. So it is not included in the Robot Framework user guide because it is a built-in library. Run process. Runs the process, waits for it to complete. So using it, we should be able to download something using wget or curl. Let's try to do that. Let's use this small test case for now. We can still log the URI to the console. We will need, we already have the process library. I wonder if it's used anywhere in the OSFV already. Some PY files. Why is it searching venv? Well, I haven't excluded it, but here it is. It is used in capsule update test case of the shard stability. Yeah, so they just give a command here, bash. Okay. Let's see if we can execute some commands using this. So let's try to download the file. Is it good to start with downloading something? Why not? I will try to get the direct download link for this firmware. Is it direct? I think if I press here and do copy download link, I will get a direct link. Yeah, that probably was not a direct link to that file. Let's try to use that one. Let's export fw URI equals this long link. I think I should have escaped that. Well, it was not great. I might have just been hacked. Let's escape such strings in the future. Yes, so this URL is accessible now. Let's try to let's maybe try to not download it for now. Just print it to be sure. Yeah, it can be accessible. Let's now try to download it actually. But let's first remove the binary. It's gone. Run process is uncommented. Maybe this command doesn't run a shell. Maybe we need to run bash -c like we seen before. Let's try that. Still not. How did it look like? Maybe the parameters need to be separated by 4 spaces. Yeah, I think that's how the process library works in Python. You need to give a list of parameters. Maybe it works in the same way. Let's try separating those with 4 spaces. Oh, something has happened. Maybe we can get the output. Result equals run process. making sure that there are 4 places between every part of the keyword. Robot frameworks requires at least 2 spaces between parts of a keyword. Oh, and also let's log the output. It's just a result object. It might be a bit more complicated. I think I have seen a keyword called just run. There are a lot of occurrences of the string in robot framework. I think run might work better here. I'm not sure if it's highlighted in this documentation, but I have used it before. I think it should work. Command not found. Let's again try to escape the string. I mean, wrap it with quotes so that it is not interpreted. And oh, this time it takes longer. So I think we have done loading. HTTP response 200. Did we download it? I think that's the file. Well, we should probably give a name to it, because otherwise wget assumes the file name from the URL, and the URL was not very pretty. How would I do that? Is there something like output file? Yeah. Let's do that in the test case. And we get this thing -o firmware.rom. That should do it, right? Firmware.rom. Yeah. So now we have downloaded a firmware file successfully, and we have logged from where the firmware was downloaded. Now what we need to do is actually use the firmware. For that, I think we should look into how OSFV is initialized when we run a test case first. There must be some preparations done. We have even... no, I don't mean to do that. Yeah, because we have this prepare test suite keyword run. Let's try to look where it is defined. I'm pretty sure it's defined in keywords.robot, so I would skip grabbing it recursively. I will just ignore the case. It is not defined there. Or have I swapped the parameters again? No. Well, here I downloaded VS Code and robot framework plugins. It would be much easier to do it. Oh, because it was prepare test suite, not case. Right, yeah. My bad. Yeah, it is defined in keywords robot. Let's see what do we have here. Yeah. We are adding some metadata. Config. Oh, here we have the code that imports the platform config we've chosen. We were using platform configs slash qemu.robot, and we have defined the config variable in our bash script that we are sourcing as qemu, and here we see that indeed .robot is appended to it, so I shouldn't have added .robot there. Import libraries, prepare to connection depending on DUT connection method. That's one thing defined in platform configs. We were using telnet, so prepare to serial connection was used. I think the most straightforward way to make sure that the firmware we have downloaded is used would be to change the value of firmware file variable. This way, any place the firmware is used, OSV will use the firmware we have downloaded. But we got to make sure that if firmware file was already set, we are not replacing it. Yeah, otherwise if someone tests some debug build, they might get confused. Or maybe if both firmware URL and firmware file are set, we should show some kind of a warning and skip the execution. Yeah, I think that might be the best solution for that. Yeah, let's try to implement it like that. What should we do? What should we change this prepare test suite keyword? It is used in every suite to for example, configure the SSH or telnet connection. I think it could be a good place. If there would be a better place, I might not be sure about that. Someone will get assigned to the bounty I am doing, and they will obviously review the changes I do. So if they don't like it, they will comment about it, and during the review we might move this to another place. But for now, let's just get something that works. So let's see if... Oh, let's not use if for now. Let's just say that... or maybe we should. If firmware URI. I wonder how can we check if a variable is defined. Because I know if it's not defined, then OSV will crash out. Stack Overflow again. Perfect. Get variables returns all of the variables. I think that's a bit too extreme, but get variable value will return none if the variable is not defined. That may be a good way to do it. Let's see if we can do that. So if the URI is defined, it is not none. Let's download the file. I have hard-coded the name of the file here. Let's keep with this approach for now. We can change it later, anytime. Let's maybe also log the fact that we are downloading something. Firmware file variable should have the scope global, so that if we return from this keyword or change the test suite, we are still using the firmware file we have downloaded. Yeah, let's try that. Let's try to test that in this tiny test suite we have created. If we uncomment those lines, prepare test suite should be run before any test cases. So let's see if we can log the firmware file. Do we still have the variable defined? Yes, so yeah, let's try to run it. Or maybe this get variable cannot be used with environment variables. But if we try to access an environment variable that is not defined, our boot framework crashes. We have seen that before. Maybe there is another way to access environment variables that doesn't crash out when it is not defined. Get environment variable, operating system. Oh, that's perfect. Let's try to use this keyword from operating system library. We can give a default value for the environment variable if it is not defined. So instead we can use get environment variable, and how do you pass the name? Yeah, you can also access directly. We don't want that with the given name, so I guess we should not treat it as a variable, just give the name of it and a default value. Default is none by default, so we don't have to do that. Let's try this. We are evaluating the string there. Yeah, using the syntax with $sign and curly braces, the value is pasted in this place in Python. It is not treated as a variable, but if we remove those braces, it would be the same as giving the variable name here, not the value. Like Robot Framework under the hood executes a tiny one-liner in Python here in if conditions. So this way we will check if the actual variable is not none, because before, by using this syntax, we have been checking if the value of the variable pasted here is not none. So Python tries to evaluate the value of the variable, the URL, and that is obviously not correct. Let's try again. Something is running. Something is running. Okay. Variable config was not found. Oh, that's because, well, we haven't set it because we are not using the wrapper for Robot Framework. To set the variable we would need to use the -v option, config, qemu, but the wrapper can do it for us, as we have already defined them. Yeah. We should have probably defined the snippet now in the file with the variables, the bash script. It would be easier this way. As an external contributor, you should always set this flag. It is a local system. By that I mean snippet. So let's try yet again. Yeah, we have downloaded firmware.rom, and that's not the firmware URL variable being read here. It's actually the firmware file, so we have successfully replaced it, right? Let's check for sure, to be sure. Test.robot. Yes, we are printing firmware file, so adding this little check to prepare test suite, we have replaced the firmware with a newly downloaded one. And if we open the logs, check the prepare test suite. Yeah, here we are checking this variable if it exists. If it is set, so it is not none, we are logging the value, downloading firmware from the URL, so we now know for sure from where the firmware was downloaded. Yeah, so I think this tiny experiment works fine. I think we are ready to commit anything. It wasn't we weren't too fast with implementing this, but I'd like to say that you should create the fork and commit your changes as soon as possible, and as soon as you have anything to show, you should link the pull request with your changes to the issue. So let's just quickly do that. Let's add the keywords.robot and commit it. Sorry, I don't have GPG set up here, and I haven't even configured Git, so let's just do that quickly. I think I used CMail. And username was Panda Bug Bounty. Yeah, let's do that again. About the commit messages, I don't think it is defined in the OSFV repository, but before contributing to any of our repositories, you should probably look into the README for some guidelines. Checking the syntax. I'm not sure if it's set anywhere here. If you can't find any documentation, you can ask for it, like how the messages should be formed. But you can always just check the log and see how the commits look like. So it looks like you should in the commit message write what you have changed, like keywords.robot, then describe the change in short. Yeah, contributors are also very often giving some more complex descriptions of what they did, so that's a good thing to do, but you don't need to do that every time. And remember that you can always change the history, so you can rebase or join, squash some comments together and modify the messages. The person responsible for reviewing your changes will eventually ask you to do that. They will help with complying to the guidelines, but for now let's just commit anything. So what we have changed: robot, that's support for firmware URI and variable. Oh, we're using nano here, not Vim. That caught me off guard. Let's push the change. Let's see if it is registered on our fork. It is, but I haven't created a branch. Let's just do that quick. We are working on a fork, so it's not a big deal. But for contributing, you should probably create a branch. But to be fair, I'm not sure if that's required if you are working from a fork. Let's just do that just for the sake of it. Let's go download firmware file from net. Get checkout B. Yeah, let's push that branch now. Again, I haven't configured Git as much as I'd like to. Normally I have it configured that it's using the branch that has the same name for pushes, but it's not set by default, so we need to define the upstream. Yeah. A new branch should appear. Yeah, we have two branches. Download firmware file from net. Let's create a pull request as soon as we have pushed anything. I think you can also create an empty pull request with no commits. If it's possible, then there's no issue with that. You can create it. How do we call this pull request? It doesn't really matter, as you will link it in the issue. Let's copy this name from here. Why not? We don't need to add the description for now. Let's just make sure that we are using a good base repository, Dasharo open source firmware. We want to merge to develop, and we want to merge the branch we have created. Let's create the pull request. Great. We want to commit to Dasharo develop. We have been redirected to the Dasharo organization repository because it is a pull request to do it. So let's just now quickly notify that we are working on something here. So from now on, a future reviewer will be able to see your changes, suggest how can you further improve it, how can you solve this issue. If you find any roadblock along the way, we will be happy to help you. So please remember to ask questions, to regularly report how are you doing, if you have any progress, and if you can't make any progress anymore, also notify us. We will help you. We have a rule here defined that if you won't be active for 1 month, we might unassign you from the task and allow other people to take it. So remember to always write something like, I don't think I am still working on it. An update will be pushed in the future. Otherwise we might change the assignee. Yeah, so we haven't solved a lot today, but I think we have shown well, the most important things when it comes to contributing. We have successfully made a contribution. It maybe is not as useful now as it should be to solve the issue, but eventually, after some rounds of reviews, after talking with other maintainers of the repository, you will create a pull request that is satisfactory, that solves the issue. It will get merged, you will get the review, and once it is merged, the only thing left is to receive the financial support. I've seen that we are given it via the FreeMDApp open source collective page. I haven't used it personally, so I can't say much about how it works, what can you expect from it. But I'm sure that someone will guide you through it, and in no time you will receive the compensation once the contribution is done. So we believe by creating this program we will promote the idea of contributing to open source projects. We will give the community a way to help us with developing the Sharo firmware or any projects maintained by Zaru's team. We will help people who want to work for us to get our attention, because I've heard that if you make some contributions, you won't even need to take a technical interview when you would be when you would be looking forward to work for us. So that's the best way to you don't need to send a CV to us if you want to work here. Just do the contributions, or if you don't want to, you can just get the cash and go. It's up to you. So I think that would be all for today. I haven't seen any more questions on the YouTube chat, nor on the Matrix space. If there are any questions, please ask them right away. We are 2 minutes over the time, but I think that's not a big issue. If there are no questions, then I would like to thank you for your patience. I hope this stream and the recording of it will be useful to you. And well, thank you. I don't think there are any questions appearing.